In number 4, I again want to determine the maximum value of the objective function z equals 4x plus 3y. And then I've got a series of constraints. All right, so first we have 5x plus 2y is less than or equal to 29. So this will be a little tricky to graph, but nothing we can't handle. So first I'm going to subtract 5x from both sides. So we have 2y less than or equal to negative 5x plus 29. And then divide both sides by 2. So I have y less than or equal to negative 5 halves x plus 29 over 2. And then I also have, this is slightly different than what we normally see, 0 less than or equal to x less than or equal to 5, and 0 less than or equal to y less than or equal to 7. So let's graph these two guys first. So for my x's, 0 less than or equal to x less than or equal to 5. So I'm going to draw solid vertical lines at x equals 0 and x equals 5. And so far I'm just being contained between those two, if I were to shade right now. All right, and then for y equals 0, that would go there. And for y equals 7, that would go there. And 0 is less than or equal to y is less than or equal to 7. So right now, if I were to shade just for these constraints, I would just shade inside that rectangle. So that's where I'm living right now. Okay, so let's go ahead and handle this inequality here. 29 over 2. That's the same thing as 14.5. And if we graph that, so if I cheat a little bit and do y equals negative 5 halves x plus 29 over 2, if I graph this, I know it's going to come down. So here's, just so I don't mess up my graph, here's my box over here. Okay, because 14.5 is, up here somewhere, this is going to be my y-intercept. I have a negative slope, so I'm going to come down something like that, right? This is what I'm expecting. So if I can figure out what those 2 points are, then I'm going to graph inside these constraints here, right? I know this is going to be a corner. That's 0, 0. This will be 0, 7. Right? That's going to be my 0, 7. This guy is my 5, 0. So I just need to try and figure out what these two are. Okay, so I'm going to cheat a little bit while I'm graphing this. And in my lab math, this would be a little easier because you could actually see your intercept, but just the way that this graph is drawn, that's why I'm cheating a bit. So right here, this point to the right, for example, I can see that this lies where x equals 5. Remember, that's that vertical line. So I know that my x value is going to be 5, and I have to fill in my y value somehow. So I can use the trace function for that, right? If I plug in x equals 5, that gives me y equals 2. Okay. In other words, if I put in negative 5 halves and then put in 5 for x plus 29 over 2, this gives me negative 25 over 2 plus 29 over 2, which is positive 4 over 2, and there's my 2. Okay, so I know that this line is going to come through and intersect at 5, 2. All right, now this other point right here, what I do know about it is that the y value is going to be 7, right? So I don't know what the x value is, but I know the y value is going to be 7. So what if I take that inequality, set it up as an equation, and I have 7 equals negative 5 halves x plus 29 over 2. And then I can solve for x. So first I'm going to clear my fractions, multiply by 2. So I have 14 equals negative 5x plus 29. Subtract 29 from both sides. So negative 15 equals negative 5x. Divide both sides by negative 5. X equals positive 3. So this is also going to intersect at 3, 7. So drawing my solid line will look something like that. I was a little bit off in estimating where that intercept would land. And this is my system of constraints. So the reason I went through this additional trouble to get these guys is just because my axis didn't go up to my 29 over 2. It didn't go up to my 0 and then 14.5 y-intercept. So I cheated a little bit to identify these 2 corner points. Okay, didn't cheat, I used algebra. All right, so shading inside the box here. This is my shaded region. And we've already talked about our corner points, but let's go ahead and list them all. So we've got 0, 0, 0, 7, 5, 0, and then those 2 points that we solved for, there's 5, 2, and then 3, 7. Okay. So remember that our objective function is z equals 4x plus 3y. And our goal is to maximize. So let's go ahead and evaluate the objective function at all those corner values. So 4 times 0 plus 3 times 0 is obviously 0. 4 times 0 plus 3 times 7 is 21. 4 times 5 plus 3 times 0 is 20. 4 times 5 plus 3 times 2 is 26. And then 4 times 3 plus 3 times 7 is 33. So our goal is to maximize the function and the maximum value is 33, and this occurs at the location 3, 7.